Friends. So good morning, everyone. So what we have seen in the last class, we have seen some terminologies about trees. So what are the terminologies that which you remember from the tree? That is types. I'm asking terminologies. What? We have three terminologies. Path, root, vertex. What about the edge? Vertex. Root. Path. Then we have seen level. We forgot to see two things. What is height and depth? Okay, so I'll just let you know what is that height and depth, and we will proceed with that in order, pre-order, post-order traversal in this session. Okay, so we will practice some problems in that. Then we will start BST, that is binary search tree. We need to apply a rule, and then you will be given some sequence of numbers, and then from that we need to form a tree, binary search tree, not just binary tree. Okay. Guys who are online, can you see my slides? Is it visible? Yes, no?
Yes, sir, it is visible.
Okay. So here we need to calculate the height and depth of this particular tree. So first let's look into the definition of that. So if you want to calculate the depth, then you need to find the edges present in path from that particular root to which node you want to calculate. Which means, what do you understand from that? So number of edges. So now, which are all edges here? So these lines, right, between A and B, right? So we need to find number of edges present from path, yeah, from the root node of the tree to that. So for example, I want to find the depth of B. Depth of B. So what the definition says, you need to find the edges present from the root to that node, which means now I want to find the depth for B. So which means from root, how many edges are connected? Present in that path from A to B, how many edges? That's what given in the definition. That's why I asked you to what do you understand from that definition. Go through that one again. Number of edges present in path. You mean which path? I want to calculate I want to calculate depth for B. So what is the possibility to go to B? From A to B only you can go, right? And then there is only one edge in that. So that's what it is. So if you want to find depth for D, what it is? D. Because from root I need to find the edges connected to this node, right? So that's what. So how about height? So I want to find the height of B again. So in that case, what is given? Number of edges present in the longest path connecting that node to the leaf node. So now I don't want to look for the root. I want to check where is the leaf node connected. So now from B, where is the leaf node? D. So again, how many edges? 1. So if there is something like this, for example, here I say F. Then, so now I need to calculate the height of B. So from this node, where is the leaf node is? Longest path of the leaf node. Okay. So that's what given in the definition again. So here I have got two edges. This is 1 and this is 2. So I would say that 2. So basically height starts from bottom. That means 0, like level. So we used to write here level 0, 1, 2, and this is level 3, right? But for height, we will start from the bottom, like height is 0, and then 1, and 2, and then 3. This is how it goes. Okay. So now what is the answer for this? Depth of B and a height of B. 1 and 1. Both are 1. No, forget about the F. Yeah. Okay. Because that's what I mentioned in that. So how about this depth? Because I didn't draw F over there while making this. Yeah. Height is 0 because there is no, child node, because that itself a leaf node, right? So it's 2, 0. Fine. I was talking about this array representation, right? And I've shown you in this way. So let me draw an array like this. So first of all, if there is a tree given, and if they ask you to represent this one in array, so what you want to do is you have to give numbers. If there is no numbers for this root, I mean these nodes, okay? So 1, 2, 3, 4, and 5. So now total how many nodes are there? 5. So what I want to do is I just want to draw an array, and I need to, in the first index, always in the first index, if you are representing binary tree in array, then you need to mention the total size in the first index, which means 5. Then you need to allocate like this. I mean, 5 in the sense, yeah, okay. So here I would say 1, 2, 3, which means E. Then A will be stored here. B, 3, 4, and 5. This is how it goes. This is how you need to represent. For example, there is a tree like this. Let me say this is here. I'm saying that again. You can say A, B, C, and D. But here the numbers are different now. For example, here 1 is there, then this is 3, and this is 4, and this is 5. So how you will represent this? This is 4. 1, 3, 4, 5. So now what should I draw? I need to draw something like this. So how many nodes are there? How many total nodes? 4. So first in the index I'll write the total number of nodes. So now here comes the problem, because we don't have 2. We have 1, 3, 4, and 5. So what happens if you allocate like this? 1, 3, 4, and 5. So now here comes, I need to insert 2. After this tree, I'm feeling that, okay, let's insert 2 root. I mean the node called as 2 with value 2. So which means it can't go here, right? Because it should go in a sequence. This is linear, right? So what you want to do is that in this case, you need to leave a space like this. You need to say 4, and that is 1, and you need to leave this index number 2 empty. Then you need to insert 3 here, then 4, then 5. So here it is initialized as 0 by default. So now whenever 2 comes, then you can insert it here. So then it will be in a sequence order, right? So likewise, this is also a possibility. They might give you a tree like this with different numbers. If it is 17, then you have to leave ... 17 like that. You can mention. Then you can go for the upcoming, the next numbers that way. For example, here 35 is given. Then you have to draw. You don't want to write 1 to 35. It will be more lengthy. You can say 1, and you can say 3 dots, and you can write 35 and all. So if 34, 33, 32 comes, you can insert in that space. Are you getting this? How we represent array in binary tree. The same goes for this linked list. Again, there is a tree given, and you need to form in this way. So here, the advantage of this linked list is that it has the address, right, of a B, left and right a child. So, and what will happen here? It will be null, basically, right? Here also it is null because it is empty. It doesn't have any further nodes over there. So we used to say null, null over here. Then if you want to insert something, for example, I have inserted, it has got something like F, so which means that it is in the right side. So you need to put right F, and then this would be null. Is it fine? So I have shown you this slide in the previous class, and then we just did something with I have taken A, B, C. Then you have done something easily in order, pre-order, post-order, right? So let's get into a similar kind of problem. So there is a tree. I need to solve this one. I mean, I need to find the pre-order of this. So I need to go to root first, then left, then right. So that's the rule. So now what will be the output sequence here? Only ABC. Then what about DE? Root A, A, B, D, A, B, D, then right. I mean E, C. Is that? This is correct. So root, okay, then left, yes, and again I have got left child. Then there is no other left child. Then I'll go to right. Then again, this left subtree is completely over. Then the right side is pending, so I'll go to right. Right? Okay. So here, whatever we do in this procedure, we have written it as an algorithm, which means what is this name of this traversal? This is one kind of traversal, which means how you move to one node to another node. So this is pre-order. So you just say pre-order of particular tree. You can say any name of the tree. So again, always in all the programs, first we say if it is null, empty. Even in the last lab we have tried. I mean, if there is no space, pointer space, then it should show null, right? Likewise, if it is not equal to null, also you can check, or if it is equal to null, you can print something. Then what happens is that it should check the tree data. Then first, what you are doing here? What is the rule you are applying? Tree data in the sense, first it will go for tree, I mean root, then left, then right. You are applying. So change this algorithm for the upcoming things in order, in the sense what you will follow the same algorithm, but either right comes first or left comes first. You just want to change it. I'll show you that also. Fine. Before that, we'll get into this in order traversal. So what will be the answer for this? Left, root, and right. Left child first, and root and right. Should I start from here? C. No, C is in right side. D, B, E, A, C. Is that correct? What you are saying? D, sorry, D, B, E, A, C. Is this fine? Is there any differences? So first you have to visit the left child, right? And so that's perfectly right. So you just consider the whole tree. Don't just say that B is in left, because after B there is D is also. So that is in the, you have to start from that leaf actually, right? If you have got only this much, like only 3 nodes, then it is very easy to make the answer, right? But what if it is a lengthy tree? Then you have to apply this concept. So first I'm just going to left child, and then here there is a root, and then right, and then now this is done. Okay, so then I'll move forward. Then I don't have any other left thing, right? I mean, left child is not there, so there is a root. So If there is no left child, then you should go to root. Yes, I'm going to root, that is A. Then I'll visit right child. Okay. So again, here I just changed that, which means first I'm visiting the left. In order, I'll mention left, and then root, and then right. So the algorithm seems lengthy in data structures, but it is not that much difficult. You just write the same procedure over there. Simple. Okay. Because if you go for stack, queue, linker list, the programs are very lengthy, and you might feel confused, and you might think that how to implement this. So don't think much about that. First, understand the concept and the algorithm first, right? So here I have got post order. So here, what will be the traversal? Left child, right child, root. So first I have to go to left child, right? That is D. D. Then right child. Why B? After D, what should come? E, because left, right, and root. Okay. Then after B, why? Because there is no further left child, so I'll go to right. Then finally I have to visit the top root, right? So A comes last. Okay. So first I'll visit, is it is left, and then right. Then this left and right tree is over, and then I'll go to the root. This is the root of this DE. Okay. Then again I'll look for left. There is nothing, right? I mean, it connects to the root node. So what should I do here? So here, then in that level, I can see that C is on the right side, right? Then finally I have to visit the root. So which means that the order will be, I mean, traversal order will be D, E, then B, then C, A. So this is very important task. Definitely you can expect this one in 2 mark and 3 mark. They will just give you a tree and then make you, I mean, ask you what is the traversal, 3 traversals. Don't get confused. In a hurry, you might write post order is root left, right. That is entirely wrong, right? I mean, you might be right in the concept, you might be right in the traversal, but by mistake you will write in order to post order to something else. So be clear in this. So that's what the answer is. PEBCA. So again, here what I have done, again, I'm just saying that if it is not equal to null, if the tree is not null, which means it has got some nodes, then I should visit, right? So I'm visiting it, which means first I'm visiting left and right and then root. That's what I mentioned it, nothing else. Okay, there is something different. This is level order traversal. So it is also called as BFS, breadth first search. BFS in the sense, whatever is, whatever the nodes in that particular level, I will visit all the nodes. For example, this is level 0, right? L0, this is L1, and this is L2. So now what will be the order of traversal for this? I said that I will visit entire level. So if I start from root, A, then B, C, D, that's it. Because it is given, right? All the nodes at level are accessed before going to the next level. Simple. So this is BFS, and DFS is something different, where if you take B, then you should go until the depth. That is, DFS is depth first search. You will go until the depth. If there is something like this, you will visit completely to that particular depth, and then you will proceed with the right side. So we will apply these algorithms on specific applications. For example, I want to do deep search, then I can go for it, but it takes a lot of time. It might get stuck in somewhere. For example, I'm searching for some file in my PC that is stored in this area, in this C node. I'm applying DFS, depth first search, and there are 10 lakh records. So think about time, how much time it will take if it is going in unknown depth like this. So it should complete all the nodes, then it should visit right side then it should come to right child. Then only I'll be getting my file names, right? So in that case, you should not go for that. So if it is BFS, in the third step itself, I will get the answer. It is in C level, right? I mean C node. So in level 2, I mean level 1, I'll be getting the answer, right? So that's how you need to select the algorithm, based on the project, which is required for your project. So this is the answer: A, B, C, D, E, because it is breadth first search. I will visit all the nodes in a particular level. So in DFS, either you can apply a pre-order, in-order, or post-order, and in breadth first search, we will apply level order, right? So that's what happened in the previous slide. So we have applied. We are going to level 0, then level 1, visiting all the nodes, then upcoming levels. So now there is some question. They will ask you to construct. They will give you in-order, pre-order sequence, okay, and then they will ask you to construct a tree for this. So how it can be done? So let me tell you the steps first. Okay. So first I need to find the root node. So where is the root node? I mean, they have given 2 sequences, okay? In order and pre-order, 2 sequences are there. So using which I can find the root node? Pre-order. So that is, it starts with root. So I can assure that A is the starting node. Okay. Then what should I do is, no, yeah. So here what should I do is that, I mean, this D, B, E, A, F, C isn't already in order. We don't want to do any changes. And that another sequence isn't already in pre-order. Now they are asking, based on this sequences, you need to, construct a tree. So now we need to find left and right tree. So how to find that one? So not from here. So I need to check with, so from here I have choose the root, right? So A is the root. Now I need to find, where is A in this in order sequence? Where is it? Where is this root node A in order? It is after E. So here it is A, right? So what I want to do is that, as you said, left and right. So whichever comes, to this left side of A, I need to take it in left side. Okay, so here it is A. So D, B, E is in left side, right? So I will mark, for example, D, B, and E. This is towards left. And what is in the right of A? F, C. So this is the first step. Then again, now I have D, B, E here. Now again, I need to make one thing as root and then to child. So again, how can I do that? So now what should I do here? So again, the sequence is D, B, E. Okay, so now I will go to this in order and check which comes first. Okay. Sorry, I'll go to pre-order and check. So which comes first? First. Out of this sequence, B. Okay, so I'll take B. Then you just see that what is there in the left and right. So if you compare this one with in order, in B, what is in the left? So D is in left and E is in right. Or simply you can take this is in left, whatever is there in the left side of D, right side of D. Sorry, D. Fine. How about F and C? Huh? Why? So where should I check that one? In pre-order, I'll be checking that, right? I mean this for F and C. So C comes first. So C comes first. So I'll take that. And then what is there in the left side of C? F. So I will draw it in the left side. This is how you should finish it. Done? So let me just erase this, and I want all these answers in your notebook. I'll give you a minute. You can make this tree. Done. If you say done, then I'll move to next. I won't check. Okay. I don't like smoking. Yeah. Hey. So make it fast. We have other problems. Next problem is a little bit lengthy. Now you're gonna guide me how to solve that. The same kind of problem. Okay. Done with this? Shall I move to the next? Yes. I said it is a bit lengthy. Yeah. So this is post order and in order. You just first of all you need to know what will happen in post order, what will happen in order. You need to find the root. So now which is the root? This is not post, this is pre, okay? Pre. So what is the root here? Okay. I will draw 1. Then what should I do now? I will go to in order and check where is 1. Here it is. Then whatever comes left to 1, then I should take everything to left. So 8, 4, 10, 9, 11, 2, 5. The computer's handwriting is very bad, so please bear with that. 6, 3, 7. I have got in the right side. So now what should I do here? Now which will be root again? No. See, I need to take this sequence and compare with which one? Pre-order. So which comes first? 2. 2 or 4? Should I go with 2? So I should compare with pre-order or in order? Did I say pre-order? I didn't say pre-order. Comparison with in order, it is in the top. I'm just checking. So it will be 2 only. Then proceed with what? So if I say 2 here, so what is there in the right side and left side of 2? Left side of 2 is like 8, 4, 10, 9, 11, and right side will be only 5. Then you have it. It is simple. Again, you will be getting another 2 or 3 steps. Are you getting the problem? Are you understanding what I'm performing here? If not, you can ask me. Can anyone tell me from the step 1 what we had to do? How to solve this? First, pre-order in order is given. So what you will do first? First, you need to find the root. So where is the root? I mean, it is in pre-order or in order? It is in pre-order. So I'll take 1. Then I need to compare that one with, I need to check with in order. Then I need to find the left and right of that particular node. Then I need to mark that one. Then from there, I will keep on proceeding. I'll take the first occurrence of this element. I'll compare this one with, what do you call that? A pre-order. And then I'll say that 8, 4, 10, 2. So 2 is occurring first. So I'll take that as root, then left and right. So that's how it proceeds. So you can solve whole left side and then you can go for the right side. I mean 6, 3, 7 you can solve further. Guys, those who are online, I request you guys to have a pen and paper and please try this. Don't just, look into your screen. You won't understand. When you practice, you will get errors.
Sir.
From that, we can understand. So whatever the exercises we are practicing, I'll upload these answers. Okay, also. If I'm not giving answers in the class, I have a file. I'll upload it.
Sir, please explain again.
Just two subtrees you will be getting another here on here one, right?
Hello, sir.
Done with the answer?
Hello, sir.
Yes.
Please explain again this question.
Can you share it? Can you present your? Oh, you have done it in the notebook.
Yes, I don't know how to take root.
Okay, no problem. Just you just tell me after this 2. I have written 5 on the right side. 8, 4, 10, 9, 11 is there, right?
Yes.
So what will be the root here?
Eleven.
Sorry,
11.
11.
Yes.
So how it is 11?
840.
You are
10,
comparing.
11.
You are comparing this one with what?
8, 4, 10, 11, 5 में से के 8, 4, 10, 9, 11, 2, 5 में से.
Yeah, 8, 4, 10, 9, 11. Yeah. So from this, which one I should take it as a root? I need to compare this one with pre-order, right? So which node comes first? You see 1, 2, 4. 4 is there, right?
Yes.
So it should be 4, na? 4.
Oh,
Then on the left side, I'll be having only 8. On the right side, I'll be having 10, 9, 11.
okay.
Right?
Yes.
So can you please correct that one? So if there is anyone who have tried, can let me know the answer. So guys, what will be here after this? 8, 4, 10, 9, 11 I have. So what is the root here? 4. Why? Because here I just compared this particular sequence in this pre-order, right? So 1, 2 is not there, 4 is there, so 4 comes first. So I'll take 4 as root, then 8 in the left side, then the rest of the things 10, 9, 11 to the right side. Okay, then so now I have 10, 9 and 11. Again I'll compare this 10, 9 and 11, 3 nodes in this what in order of pre-order, right? So I'll say first time we will check for the in order, I mean to decide left and right, then we have to compare pre-order. So and then there will be 9 first and then 10 and 11 here. And how about 6, 3, 7? 3 is root, yeah, of course, 3, and then I have 6 and 7. So kindly complete this, copy this, and you just write in a new sheet, okay? Whether you are getting this answer or what. Check with that. So I have 2 exercises for you. You just copy this and let me know the answers in the next class. Yeah. I mean, next session. Yes. Next class in the sense next session. So when we meet next, that's what. Then don't ask me if we meet afternoon lab sessions should we give. Okay, it's no theory sessions. So please copy this in order and post order. And I have a lengthy exercise, 2 exercises for you. Huh? Yeah, yes. Just copy this. So 15, 30, 35, 40, 45, 50, 60, blah, blah, 70, 72. You will get this type of questions for your midterm. Maybe 6 mark or 8 mark or 4 mark, like that. Huh? Yes, of course. You need to show the steps actually. First, what is the root? Then second step, it will come like 10, 12 steps. We are drawing in one tree, na? But you have to do it step by step. How you are getting these steps? That's what you have to show. Yeah, guys, remember during your exams, don't just draw a single tree. You have to show step by step. First step is you are saying this root. Then second step, like that. So it will come around 10 to 12 steps. Depends on the problem. Because those who are copying, they will simply draw the tree. Then they will say answer is finished, right? So there should be some steps. Done with this? Have you copied? Yes. So we should be faster than online people. You know what online students will do? They will just take a screenshot. So we need to be faster than them, right? Like we have to write and all. Okay, so in order, so do you have any queries in this in order, pre-order, post-order? And how to construct a tree from in order, pre-order which is given, binary tree. Will be given some order, then you need to form a tree, right? So the next concept is binary search tree. So here we apply some rule. We don't simply draw a tree. While drawing a tree, we used to say that, yeah, I'll go with this. I'll just introduce this topic and then we will see the problem in the next class. Okay. So this binary tree has got this properties, which means each value, that is key, it is not going to repeat. For example, we have a root and then different childs, left and right and all. So the numbers won't get repeated. I mean, there won't be duplicate values. Fine. And then we need to compare always whether it is greater than root or less than root, always. Okay, while making a tree. So here the rule is, for example, if you are, I have three numbers. Let's say I have 5 and then 10 and then 15, 3 elements. I want to make a tree. So now what I go for is, like, I will say that 10 I'll take. Yes. So I should insert 5 towards left because it should be less than the root, and then 15 in the right because it should be greater than the root. So this is the rule here. Okay. So left subtree should be less than the root. Okay, always. And then right subtree should be greater than the root. Okay. So can you go through this tree and could you let me whether it is satisfying these two properties or not? So this is a root and this is left, which is less than the root, and this is in the right child, which is greater than the root, right? And again, if you see this, if you take this as root, 5 is less than. First, before inserting 5 here, you need to check here, because see, this is just a tree I have given the final answer, but again they will ask you to draw a binary search tree with a sequence of numbers like this. For example, now you need to construct binary search tree for this particular elements, which means now you will take 45. Okay, then 39. 39 is less than 45 or what? Less than in the sense where it should go. It should go 39 here. Yes, 56. So, and then 12. So when I compare this one with 39, it is less than or right greater than. When I compare with 39, it is less than. So it should go left. So in this way, I need to construct. This is also step by step, right? So always first we will compare with this root and then this one and then this one. If satisfies, you just put it in left or right. Okay. So we will do this exercise by the next class. I'm just letting you know there is a concept called BST. So don't get confused. This is why I'm asking you to practice. Always you have to draw trees. You will be given some sequence. They will ask you to draw, a binary search tree, or they will give you, in order, pre-order, something like that. They will ask you to draw a tree again, right? Because in binary search tree, we will perform insertion, deletion, and search. We will first understand how to make that tree. Then we will insert some random element. Then, we have to check where it should go. Then we will delete it. We will do search, right? So this is a practical stuff also. And okay. So is there any queries for today? All right. So guys, please try to solve those problems which I have given. Once you solve it, you will get it. If not, then let me know in the next class. I'll be guiding you in that. Fine. So those who are online, they can post the attendance, please. So I'll end the session here.